Hey, hi, how's everyone doing? How did things go yesterday?
For me, it was kind of hard, the first one, not
What was
the terminal.
what was hard about it? Well, not the terminal, but the first one.
Mhm.
Was it
I
difficult
don't
just
think
like
I was,
understanding?
yeah, probably. I don't think I've fully grasped on the subject just yet.
That's okay. It's more of a we're not going to really continue too far with it today. Again,
Uh,
it's more of a here's the old difficult way that you might still encounter. And again, the examples I gave you are contrived. They're not realistic, right? It's kind of something to get you to do some work and to get your fingers going. Hopefully, you understood a little bit by the end of it too. That's kind of what I have going for. Any other feedback? No. Okay. So let's take a look at it and let's go through it. And any questions, I'll do my best to answer. So for LTLMS, share my screen. Screen one. And I'm going to try to do most of my work in the terminal as well. So you can see me navigate around and do stuff. If you have any questions while I'm going through, feel free to ask as well, okay, about that. Just because there is a physical separation of one lecture to the other doesn't mean I won't answer any questions about the other stuff as well while I'm doing it, okay? So you can see my screen here. So we're looking over here at offline first applications using JavaScript. So intro to async. So I gave you this pyramid of doom and I asked you to convert each nested callback into a standalone function. Oh, sorry, using the previous, insert some code that will print out odd in addition to the number, but only when the counter is odd. So all I'm really doing is I'm coming here and making a small modification, okay? So what I'm going to do to start is I'm going to create a new file. Okay. I've never done this on my bash part before, so I don't actually have a directory. So I'm going to make a new directory called, let's call it practice. We'll go into practice here. Okay. I'm going to create a new file. Yesterday, I showed you how to create a new file using touch. You can also create a new file with the word code. Code stands for VS Code, and it will open VS Code, and it will also create files if those files don't exist. So I'm going to say this is practice.js. So this will open my VS Code with a new file called practice.js. And there we go. So the only problem, I've got a little problem with this, but nothing major. So we're going to copy this code here. And we're going to paste it into VS Code. Okay. And I asked you to essentially just put a little if statement in here saying if counter mod 2 equals 0. That means it's even. So actually it's if counter mod 2 is not equal to 0, right? That means it's odd. Then we console.log. Okay, so that's what I'm asking you to put in there. And not difficult, right? The only challenge is putting it in the right places. So here, 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 and here, okay? And again, I'm not trying to challenge you, or confuse you. It's about demonstrating how ugly this stuff can be. And yeah, again, it's contrived and it's made to look ugly, but in reality, the stuff that you would deal with would actually look way worse. okay, because it would be way more complicated. This is just a repetition over and over and over again. And if we go and run this, I don't have, interesting. I don't have a play on here. Huh. Interesting. Okay, cool. Sorry, I'm just also learning my new setup at the same time here. Let's see if this works. Yeah, and it works. Great. Okay, so 0, odd 1, 2, odd 3, 4, odd 4, 5, et cetera, et cetera. Okay, nothing super special about that. Any questions about that one? Yeah, that's kind of an easy hit. Okay, fixing the pyramid. So this is where it gets a little tricky. Okay, so I looked at this with you in class yesterday, and that's essentially, so I'm going to undo all this. Actually, I can keep it, not a big deal. So I'm going to fix this pyramid. So instead of it being a pyramid of doom, what I'm going to do is I'm going to make top level functions out of all of these, okay? Just like I did in class. So what that means is I have this if counter here, right? So step 1. So essentially I'm starting with step 1. Step 1, 500, right? So this will do a set timeout and it will call my function, step 1, after 5 or half of a second. Inside this function, it's going to call the next function. So your job is to do this, step 2. And step 2 is the same thing, except it calls step 3. And you repeat the process. Step 3, call step 4. Right, so this is, we're actually getting the same type of output from our code. Okay, so we have, it's still asynchronous. It's still step 1 calls step 2, calls step 3, calls step 4, calls step 5, but they call each other after half of a second. Okay, so these things, so this is doing it in a top level function. And again, it is better than, it's a way to do it asynchronously, and it's better than the pyramid of doom that we've seen already. Okay, but it's definitely not great. You can see that they're very, all of these methods need to be named. So these ones, the difference is these methods are not named. And that's actually kind of nice. I mean, but this is definitely advantageous. But you have to have a function for each one. Okay, and they have to be named. And then you can, I'll just go up to 6 here. Okay. What do we go up to? 8? Let's just go up to 6. 6, 7, 7, 8, 8, 9, and 9. And then 9 will stop. One of the really, really interesting things about this, though, I'll tell you, and that I'm missing. I am missing one piece here, so it's actually not that interesting. We need to say let counter equal 0. Get the counter going at something. And then we can run this whole thing.
You don't have counter plus plus in functions.
Okay. So I have to go add counter plus plus in all of them. Thank you. Oh, I'm not even console logging counter. We should probably do that. There we go. So before I call set timeout on the next one, I should be doing that. There we go. Okay, that was number 2. Just going into top level functions. So showing you a different way. So doing a different approach. So I did both of these in class yesterday. Okay. Third question is I asked you to break it up. So I gave you this load script file here, question 3, Q2. Okay, and I wanted you to go to your repair solution. And I think I gave you a solution for repairs, so I'll just grab that. Exercise, that's from here. Assignment 2. Right, so what I would do here is I would take these and then split this whole thing up into 2, right? So we'll make a new file here. Say we'll call it part1.js. And then we'll say a new file, save part2.js. Okay. And all I'm going to do is I'm going to split it up wherever. Doesn't. So here, this looks like a good spot. This one will contain the classes, and the rest of it will contain me using those classes. So this one's got 2 classes in it, and this, oops, not used to these hotkeys. There we go. Control D minimizes all your windows, and it's right beside Control S. So part 1, okay, so I split it up into 2. Okay, I just picked an arbitrary spot. Doesn't really matter. Okay, not the point. Okay, not the point. The point is what we're doing is we're splitting up this file and so we can load it separately. But remember, if we load it asynchronously without waiting on the other piece, right, they might load in the wrong order, as I showed you yesterday in class. And again, contrived example, right? But the idea is what we want to do is we want to set up a system. So we're like, okay, I'm going to go and run this stuff, but this other code is waiting until that code is done. The rest of the program is still running, okay? So we've got pieces of the code that are waiting. So we wanted to do something like this. So I set it up, I split it up into 2. I want to load script on part1.js, okay? And then the callback I want to provide is part2. Load script part2.js. So what this is going to do is, excuse me, this won't run this line until this is done, right? This is a callback. This is saying run this function after you're done doing whatever it is you need to do, which is loading part 1. So this will ensure that part 2 doesn't get loaded until after part 1. Okay, so that's all I wanted you to do, is to split up your code into at least 2 parts, okay, and then load the script using the load script function that I gave you, just to demonstrate how callbacks and asynchronous code can work. Okay. Any questions on that? Nothing. Okay, beautiful. Okay, so again, the exercises on a daily basis are quite short because now really I've only got 45 minutes left for lecture. So that's awesome. Again, this is a little bit contrived, but I just want to show you some stuff and get you to a kind of an understanding of what synchronous and asynchronous is, blocking versus unblocking, which we talked about yesterday, as well as managing asynchronous code with callbacks, because we're going to continue to manage asynchronous code. The rest of the code that we're going to be writing for this course is asynchronous. Okay, and it's nothing to be scared of at all. We have a lot of really easy tools to deal with it. And it makes a lot of sense, I think, once you do it enough times. So let's get into our lecture now. Just a quick, I just want to show you, see all my files are now in here. Timestamped. I did an LL, which is a ls-l. Okay, I have it's a built-in shortcut, ls-l. So all my files are in here now under my home directory. I don't like this color. It's a little bit dark and hard to see, but okay.
I have a question. I tried LL in my terminal. It didn't work.
Yeah, I have. I might have this set up as alias, which we'll learn about today. I can't remember. I carry my stuff around from computer to computer, so I don't remember what I still have, what still is on this computer and what came from the previous computer. So yeah, that's very possible. And it may be possible that, also keep in mind that you're using a Mac. I'm using, this is Linux, right? On the left-hand side, this is Linux. So there could be a difference there too. But I bet you I have a shortcut for it. I don't. Huh. I would add one. We'll add we're going to add aliases tomorrow anyways. Okay, so new stuff today. So we're going to go find our lesson 2, intro to promises. Yeah, all right. So bring that over, okay, sure. Bring that over here. And I'll get a new code going, some sample.js. Okay, so today what we're going to do is we're going to learn about something called promises. Okay, so yesterday we saw how to handle asynchronous code with callbacks. And as you can see, it can get a little bit crazy and a little bit it can become a little bit nonsense. Okay, but for a long time, that was how we had to deal with asynchronous code. So code that runs it almost in parallel to other code that's running, right? It starts, it gets something going, and it almost like does something in the background while the rest of the code is working. But we always need to be able to, when that code is done, we kind of need to be able to come back and say, oh yeah, that's right, you're done your thing now? Okay, well, I'm gonna do this based on the result of that thing that you were working on, right? The water boiling while I'm cutting the vegetables, right? When the water's done boiling, I have to go back and attend to it. I have to put my pasta in, right? It's done doing its thing. While it's working, I don't have to do anything about it. Actually, I think better yet is probably putting things in the oven and baking them, because you actually have to go back when they're done and take them out of the oven. You can do other things in the meantime, but when they're done, when that timer goes off, you got to go get it. Okay, so instead of callbacks, because callbacks aren't very good, in ES6, they came out with something called promises. Okay, so a promise is a lot like what you would expect a promise to be. It's, I promise to come back and deal with you in a bit. Okay, so that's what we're going to be creating, something called promises. And today and tomorrow, we're going to build blank promises. And it's kind of like how we did it with objects, right? We learned about objects initially by creating generic objects, right? Just capital O object, or just the curly braces, right? But then later on, I introduced classes and the fact that we can create our own objects. So we're going to kind of do the same thing with promises. So promises right now are going to be really kind of abstract and like just super generic, just the word promise. But in a couple days, I'm going to show you how promises are actually used on a day-to-day real life basis. And we're no longer going to use the word promise anymore. Okay, but we're going to talk about promises, kind of like how when we were doing the repairs, we're talking about repairs, but repairs are objects, right? Transactions are objects, but we're still talking about transactions. So we're going to kind of take that same path, that same format. But so we're going to start today by learning about just basic promises, okay? Generic promises, okay? So this is what a promise looks like, okay? And I think once I show you and we go through it a little bit, we'll have a better understanding, okay? So we have this guy right here. So this is the syntax for a promise, okay? And the syntax shouldn't look that unfamiliar. We have, it's interesting. We have new promise, okay? So obviously a promise is some sort of object, okay? It's not an int, it's not a string, okay? But it's a promise. We're creating a new instance of a promise, and we're storing the instance of the promise into learn.js, just a variable. Promises take one callback function as a parameter. They take one parameter, and it is a function. And that function is the code that is asynchronous, okay? So the code that is allowed to run in the background, okay? So we're essentially creating a block here around, right? So this is the entry point to the block, and this is the end of the block. And we're essentially saying, this is the code that we're given the green light to go run in the background, okay? The rest of our code will continue to run even though the code that's inside of here is not done. Now, in our case, this code that I have highlighted is not doing anything interesting. In fact, it's not taking any time, right? I'm not pausing anything. I'm not doing anything complicated. I'm not looping through something a million times. I'm not setting a timer. Okay, this will just go really quickly. But we're just talking about conceptually right now, okay? So that's pretty much what goes inside of the promise, okay, is the code that's asynchronous. And we have controls over whether or not the code that is being run was successful or unsuccessful. One of the things we didn't do yesterday when we were due, but I hope you saw in the reading, because I did give you readings, right? Yeah. I hope you saw in the reading was adding error handling, okay? For example, sometimes when you try to load a JavaScript, maybe you gave it the wrong string, or maybe maybe it couldn't be loaded. Well, what happens to the rest of your application when that happens, when your JavaScript can't be loaded? An error. And we have ways of managing errors, okay? In promises, they're built in. Okay, so we have two different ways of handling these things. And it's not really errors. We can use these any time, however we want. But we have kind of thumbs up, let's keep going, or thumbs down, things didn't turn out as I planned. Okay? So we have inside of our promise something called resolve and something called reject. If the work we did, the work we did being this stuff highlighted, which is whatever, right? Could be whatever. If the code we executed and we're satisfied with the result occurred, we would call a function, because this is a function. We as developers are not supplying these. JavaScript is supplying these to us. Okay, JavaScript is providing us with this resolve function. I don't know what it looks like. You don't know what it looks like, but that's okay. Okay, so this resolve, we can call it anything we want. R, J, we can call it anything we want, but JavaScript is putting the function in there for us. Okay. Once we're satisfied with what happened, we can call resolve, or we can call reject. Okay, if we're unhappy with what happened. And those will trigger different things to occur to our promise. Okay, let's take a look at this promise. Okay, what I'm going to do is I'm going to bring this over to the browser because that's an excellent place to look at promises. And I'm going to paste it in the browser. Oh, oops.
Let's
Yeah.
continue.
Yeah. Okay. Oops. Okay. So my promise is called learn.js. And when I look at my promise, it has a status resolved, okay, because completed is true. So what happens, I set completed variable called completed, it runs my promise. If my variable completed is true, I resolve my promise, and it has a value, and the value is the value that I sent into resolve. I can send anything I want into it, and you'll see why shortly, okay? But that there is a value, and the value is just a string here, okay? But this value will be anything we want. We can control that. If completed was false, the status of the promise will be what? What do you think this? What do you think the status would be if completed was false?
Rejected.
Yeah, rejected. Yeah. So resolve occurred because this, but if completed is false, it will go over here and the status will be rejected. So let's go take a look at that. Let's try that. Not only that, but it actually threw an error. Pretty interesting. Okay. And it's not the same, like there's not an error in my JavaScript here, okay? But rejecting forces an error to occur. And the error message is, I haven't completed learning JavaScript yet. Interesting, hey? So let's take a look at that promise. That promise is still there, it's still good, okay? And we can check the promise status, rejected. I haven't completed learn.js yet. And the error shows up as like an error in our console. Okay, so typically the idea behind this is if everything was good, we call resolve. And when I say if everything was good, right? Remember, we are in control of what happens in here. So we're writing some code, we're doing some stuff that's asynchronous, right? That's not in the same, that's not occurring at the same, that is occurring at the same time that this stuff. It's not, this stuff outside the promise is not waiting, okay? So we're writing our code, and at some point in time, we're done our work, right? We figured out our work. Maybe we went out, we got something, maybe we're loading scripts. If everything worked out great, all the scripts loaded, everything loaded perfectly, awesome. We call resolve. If something happened, we call reject. Okay, so we're in control of which one we're using. Okay, in our examples, they're going to be pretty simple for the first couple days. Okay, just going to get you to like do numbers and do counting and just dumb stuff. Okay, just to get used to the syntax. Now, I'm going to wrap this in a timer to show you something else. Let's do a set timeout function. And let's go for 5 seconds. So I have some time. Let's go for 10 seconds so I have some time. Okay, and we won't, so now I want to show you 2 things. One, that our promise is non-blocking. Okay, so non-blocking, meaning even though this is run, it does not, this piece of code does not wait for this piece of code to finish. Okay, so hi there will be printed out immediately. Okay,
isn't that 1 second?
1 second, yeah.
Oh, thank you. Thank you. Yeah. Okay, so 2 things that we're going to be looking at. One, console.log hi there is going to be printing out immediately, which means promises are non-blocking. Okay, non-blocking means they don't block the rest of the code from executing. And the stuff that's working inside of them is going on separately, okay, at the same time, simultaneously, asynchronously. Okay, so we're going to bring this over here. We're going to refresh this, okay, and we're going to paste our code. Okay, so hi there. And I'm going to take a look at this promise. Let's look at the status. Huh, pending. So prior to a promise completing, the promise has a status as well. It's working, right? And eventually, hopefully, the promise will complete, right? It will either, so there's 3 statuses for a promise: pending, resolved, or rejected. Pending, meaning it's still working, or it has not yet resolved or rejected. That's essentially what pending means. Has not yet resolved or rejected. And then we have resolved, it worked, right? Or rejected, it didn't work. Now, what does it mean it worked or it didn't work? That's up to you, right? You're the programmer. You decide when you call resolve and you decide when you call rejected. In all honesty, you won't be calling rejected a lot, okay? We're going to be doing a lot of resolve. Okay, great. So if we think about this in context of our last example, okay, what were we doing with set timeout? We were console logging. Console log a counter, right? Something like that. And at the end, so we can just resolve. We don't need to resolve. We don't need to resolve and reject. Okay, like the way I have it, I guess, it doesn't really matter what we're doing here. So after a certain amount of time, it prints out the stuff. And inside the set timeout, just because set timeout is also asynchronous, this is where you need to call resolve or reject. But we don't need to call resolve and reject each time. If we want, we can just call resolve. Okay, but you can only call one of them. These are kind of like return, right? We can only call one, and whichever one we call first is the one that is the one. So watch what happens if I put resolve again lower here. Okay, this resolve will never happen. The second one, only the first one will happen because the promise is already resolved. Okay, so it's resolved with hi. It doesn't get resolved with hey. Okay, so we can only call resolve or reject it. We can't call both, and whichever one is called first. So like, even if I made this rejected, or reject, sorry, reject. Even if I made it reject, it would still be resolved. This would never happen, okay?
Oh, I try that. That will happen, but that will throw an error.
Let's see. You got a different result?
Oh yeah, I tried it yesterday. I cannot remember exactly. Yeah, it's okay.
Okay. Well, there might have been something incorrect being done, but this is technically that's the rule, right? Only one of them. Okay. So cool. All right, great. Now, how is this asynchronous, right? So if we're thinking about it, right, this is what we have so far. We have the ability to put food in the oven, okay, right? That is our ability so far. We have the ability to put food in the oven. And while the food is in the oven, we're chopping carrots, okay? So after 10 minutes, the food's going to be ready. 10 minutes, let's say 10 seconds. Set timeout. Set timeout. We're going to resolve, just resolve. We're not going to reject, okay? We don't have to do both. We're just going to resolve. And we're just going to pass in a number, 10. Okay, and we'll do this after 10 seconds. Actually, we'll pass this in. Okay, so this is what I have so far. I have the ability to put food in the oven. While the food is in the oven, I can go and do other stuff, right? But what I'm missing from this asynchronous stuff is how do I respond to this food being ready? What happens when the food is done, right? That's what I'm missing. How do I deal with this food being done? A promise is, I promise to come back and deal with you. So far, I'm not coming back and dealing with you. All I'm doing is I'm setting up this structure that says, hey, I will let you know if the food cooked successfully or if there was a fire, but you still have to deal with it, right? So we are not dealing with it yet. So this is how we deal with our promises. And this is really interesting. We can do this anywhere, okay? It doesn't have to be connected to this. So we take our promise, food in the oven, and we attach what is called a then. And then takes two arguments. the first argument, they're both functions. The first argument is the success function. What do we do when it was successful? The second argument is what do we do when it failed? Okay, now in our case, this will not fail. But if we were to call reject, this block of code would run. When we call resolve, this block of code will run. Okay, and the parameters we accept into these is this parameter. So resolve is essentially calling this function. If we did reject, we'd essentially be calling this function. So let's start with simple, what happens when the food is ready? Well, we console.log, turn the oven off. Because plus because food is ready, right? I'm taking that in, I'm going to print it out using quotes. I don't know why. Okay. So successful. Now I won't do anything here. Because it didn't reject. So I just won't do anything for now. Okay. I know it didn't reject because I looked. Okay. We're just going to look at one side for now. So let's go take this over here and we'll refresh. Oh. So it takes, oh, it only takes a second for my food to be done. I thought it was 10 seconds, but I made the same error. So let's take a look at this promise. Hey, it's resolved. Cool. How about that that stuff that I said about the then over there, right? Like, how about this? Well, the really interesting thing about promises is they don't just evaporate and release the value. So this does not need to be attached to the promise just yet. I can attach this to the promise anytime I want, even after the promise has already been resolved. Because a promise might take half a second, quarter of a second to resolve. And this, my then, might be way somewhere else in my code. That's okay. The promise will hold on to its values until it cares and someone comes to get it, okay? So this promise has held on to its values. Now I will come in and I will use those values. I'll be like, oh, I'm here to take the food out of the oven. I know I'm 2 minutes late, that's okay. Turn the oven off because food is ready. Okay, so I can come in anytime and take out that food because it doesn't burn in there, right? It's okay. It doesn't release those values. So I'm able to come along anytime and pull that out. Now, typically you wouldn't do that, but I just want to show you that the promises holds on to their values that they've determined, this resolve, right? Even though it called resolve and there was nothing there listening to that resolve, that's okay. When something shows up and is there to hear it, then they can respond, okay? If I'm working with the cooking food analogy, just because there's no one around to hear the alarm doesn't stop. The timer doesn't stop, right? When someone finally walks in and hears the timer, then they can go remove the food. So we can do this whole thing at once. I'm just going to switch this to 2 seconds. Okay, so the promise is going to run. Chopping carrots is going to run. Okay, and actually, I'm also going to chop onions while the food is in the oven. And notice notice that my then is in between chopping onions and chopping carrots. My then is also non-blocking. Okay, so this doesn't block code from running, and this doesn't block code from running while it's waiting. So these guys will run. Chopping carrots, chopping onions, 2 seconds later, the food completes, the promise resolves, turn the oven off, food is ready. Okay, that is our asynchronous code using promises. Okay, let's take a look at reject. Any questions so far, actually? Awesome. Okay. Let me make sure I'm covering everything here. Right.
Sorry, John, a quick question.
Yep.
So the value for resolved is like automatically passed in for the first parameter for then, right?
Mm-hmm.
So
yeah, you can only actually ever take one parameter, and it will just be whatever you passed in. Yeah.
Okay, thank you.
Yeah. So this can only ever be one parameter. I don't believe you can pass two.
Hey, John, I have a question too then.
Yep.
After you then.
Okay. Let's just check to see if we can pass in two here. I don't think you can, but I've been wrong before. Yeah, can't pass in two. It only accepts one. There's something going on in between here and here that's being hidden from us. And so I don't exactly know why you can't pass in two, but it's definitely not directly calling this function. There's a little bit of JavaScript magic going on in between those two things occurring. So there's something in the middle proxying that passing of the variable. But yeah.
Okay, thank you.
Kevin? Yeah.
Yeah, so in this case we're using a resolve, but let's say we had an if and it landed on a reject, and then we called a then with the val. Would it just output whatever the reject was?
Yeah, okay, so let's talk about that now. So instead of resolve, let's do a little random number thing here. Let's do a let random number equals math dot random, okay? And we'll say if the random number is greater than 0.5, okay, then food is ready. Okay, random numbers, math.random is a function, and it generates a random number between 0 and 1. Okay, everything else is just us playing with that random number. So if it's greater than 0.5, we'll resolve. If it's less than 0.5, we will reject it. Okay, we'll reject it. Food is burnt. I don't know why it would be burnt. We're sitting there listening for a timer. Let's just pretend that, okay, we don't want the food anymore. Okay, so reject will call this function, error. The second function, the reject function. So something that's really interesting about it, you remember the first time we ran this? And actually, I'll show you again. The first time we ran this, it printed out an error, right? It said uncaught error or something. Well, we'll look at it again. And so it will call the second block of code in the then. So this, get used to this type of syntax, okay? Then is accepting two arguments, okay? It's accepting a function and a second function. It's accepting 2 blocks of code, okay? It's accepting a block of code that we want to run on success, and it's accepting a block of code that we want to run on failure. This could have looked like this if you wanted it to. Right? Inline anonymous functions versus named functions. We're passing into, but this is what it looks like in a different perspective, just to give you a sense of how this is working. Okay, what's going on. Turn the oven off because food is burnt. Okay, so fail, reject, we'll call fail. Resolve, we'll call success. Okay, so let's take a look at this.
In your fail, should the second
Line
function
25.
be
Sorry, line 24.
var instead of VL at 24, line 24.
Okay, all right, so let's try this. So math.random, generate a random number. If it's greater than 5, food is ready, otherwise food is burnt. Okay, so we're gonna have to run this a couple times, I suspect. One time, there we go. So it failed. So if we look at the promise, we can still look at the promise, food in the oven. And we can see that the promise rejected. Okay, we can always still look at that promise and see that the promise rejected. In fact, something that's really interesting, even though I already handled this promise, I can go back and I can handle it again. Okay, it never really expires, right? So I could actually come in here and change this, and I can attach another thing, fail 2, and we'll do a function 2. So it is technically still broadcasting, and it still can be connected to. So I'm going to take fail 2 and I'm going to attach it to, so I'm going to declare my function and then attach it to that promise, which already ran, has already been rejected. And I can show you, I can attach more things to it. Right? I can attach as many functions as I want. If I want 2 things to respond, oh, the food's ready? Okay, I'm gonna go get the food at the oven. You go greet the guests at the door, right? Maybe 2 things are happening that are independent. I don't know, okay? I just wanna show you that like, it's still there. The result is still done. We can attach something else to it at any point in time. It doesn't actually get consumed, right? It just, if you think of it, it's continually broadcasting, right? Rejected, rejected, rejected. Anyone care? Does anyone care? It's still broadcasting. It never dies. Okay, so we can connect as many things as we want to it. And it's pretty rare that you would ever see that happen, but just curiosity's sake, just so we fully understand how these things work. Okay, questions on rejection. So, one of the other things that you probably notice that nothing is red. There's no red lines. But when I run this promise, this is the interesting part. Oh, I'm just getting used to my keyboard shortcuts here. With nothing, something red shows up. When we have something there, when we have a then that handles our fail, where's our, I took away the then. When we have a then, that handles our fail, we're doing something which we call catching and managing the error. Okay. So this is an error, or also known as an exception. Okay. And it's uncaught. It is not being handled. It is not being managed. Okay. Because we don't have anything sitting there to manage it, right? This is managing that error. Okay, so this is kind of another concept in programming that we as developers can actually, we typically are the ones throwing errors, okay? As we start to develop more and more applications, we'll see that we are intentionally doing these things, okay? Because we want people to manage it. So what this is saying is we're not managing that reject. We should maybe be managing that reject, don't you think? If you want to get rid of this red stuff, go put this second part on here. Okay, so uncaught, it's uncaught. It's an uncaught exception. So we need to manage it. And when we attach this to it, it gets managed. Now, if that, and you see it's gone, that red part, gone. It has now been caught. It has now been managed. Does that make sense? Okay, reject is, we kind of use reject for errors. Okay. Last piece here, I think. We don't have to, I personally don't like this syntax, and you will find that most people don't use this syntax, this then syntax. Instead, this then syntax that contains a success and a fail, 2 parameters. Instead, what people usually do is they don't usually include the fail. And instead, there is another syntax called catch. Okay. So we can also catch errors. So this is the same as this. It's just a different syntax. So remember how it said uncaught exception or uncaught error? Well, the error was thrown, but no one was there to catch it. No one was there to receive it until we put this on and someone was there to receive it. That's why this is called catch, right? So we're there to catch that reject. We're there to catch the error. So if I were to take this and brought this all to the console. Oh, right. Yes. There is a interesting syntax here that I neglected to show you. Okay, so that worked, okay, no problems, but it did say uncaught, okay? And I believe that is because I didn't do this. So interesting syntax, you can chain these things together. And that would probably be the right way to do it, okay? So dot then, dot catch, and they will both work, okay? There we go. So we got rid of that error. So food is burnt. Turn the oven off because food is burnt. Has this ever successfully run yet? I feel like it's always burnt. I need to see this. I need to see this number. I don't believe that is always greater than 0.5. Okay, oh, there you go. So turn the oven up. So just to show you this syntax, this food is in the oven dot then dot catch works. Okay. Actually, this is the more appropriate one than this. These are separated. These are separate. Okay. This is separate. This is not the same. This is not the same as this. Those two are not the same. So this and these two are not the same. This is the same as this. Okay. This.
Sorry, do you lack of dot then?
Sorry?
Do you lack of dot then in line 27?
I am right here. So I'm saying, so this line, okay, so what I'm showing you, oh yeah, sorry, thank you. Yeah, okay, so this is the same as this, whereas this is the same as this. Sorry. Or doesn't matter. Okay, so these two are equivalent and these two are equivalent. Do you see the difference? So this one is calling success, and this one is attaching a success, and this one is attaching a catch. This one is attaching only a success, and this one is attaching only a catch. You can do this. This is allowed. All right, this is JavaScript. We're allowed to pass in whatever the hell we want. Okay.
So if you pass in undefined, let's say for line 34, if the parameter succeed, will you still get an error?
Yeah, you'd get an error. Yeah, okay. Yeah. You still have to do things correct. Yeah. So, well, good question. Like, if it was successful, this would happen. Can you do undefined, or does it have to be null? I actually have this written down. Undefined. Yeah. Yeah. You technically in this one, you don't have to pass a secondary, but if you do want to attach a fail and not a success, you have to do undefined, right? Because that's how parameters work. You can pass in less parameters than the ones that you want, but if they have to be in order, if you want to only provide the third, the first two have to be undefined. Okay, that's how parameters work in JavaScript, or arguments work. Okay, so these two are the same, and these two are the same. And we wanted to replicate this one. So this is so it's a little bit different. Food in the oven, dot then, dot catch. Both of these are live and ready, right? I'm either going to catch it or I'm going to, it's either successful, right? In this case, this one will run, or it's not successful, in which case this one will run. Okay. Sometimes you'll see it like this. Or like this. Okay. Depending on the length, because this actually might be a function, right? Like I said, we don't name our functions very often. They're usually anonymous inline functions. So that's what it would normally look like. So I would honestly get used to this syntax if I were you. This is the one I would go for. One more piece, and then we're done. So what I'm doing here is not particularly ideal, declaring a number outside. I like to be able to pass in variables, values into this promise. And it's nice to wrap this promise in a function. You'll see this very often, that I'm taking this whole promise and I'm wrapping it in a function. Because I may not want this promise to, like when we have it like this promise is running right away, immediately, it starts running. Okay, as soon as line 3 hits, it starts running. And that may not be what we want, right? We may want to control when it runs. And so in order to do that, we kind of have to do the same thing that we do with all our code, right? If we don't want things to run right away, we put them in a function. And then we call that function, right? Food is in the oven. The problem here is food is in the oven is no longer a promise. It's a function. But if we returned the promise, again, get used to this, this is common. We're returning the promise. So technically, this just still works. Okay, because food is in the oven is essentially equivalent to a promise because the value coming back here is a promise. Okay, I mean, it's really no different than what we had before. Food is in the oven is now a function that returns a promise. Now, this also gives us the benefit of being able to pass in variables into our promise that we can use, like random number. So I can do stuff like this, which I couldn't do before. So I can pass, so remember, this is a function, so it needs to be invoked, okay? And I can pass in a variable, an argument, into my function. This turns into a promise, which then gets a then and a catch applied to it. Oop. Oh, there you go. No different. Everything is still the same. You can run as many times as we want. There we go. Food is burnt. Everything still works exactly the same, almost exactly the same. I just had to put parentheses on here and put an argument in there to go into here. So this is how you can pass parameters into your functions that contain promises. This pattern is exceptionally common, okay? Because obviously we want to control when these promises are running. We don't just want to run them willy-nilly. I don't put my food in the oven until the food has been constructed and is ready to go in the oven, right? And so we need to, once that happens, then I'll call my put my food in the oven. Okay, so actually all of this stuff, chopping carrots and all that, that's all happening before I even put my food in the oven. Because I don't even generate that promise until here, until line 27. That promise doesn't even start running until line 27. But line 29 starts executing right away, as soon as I do put that food in the oven, because again, it's asynchronous. Promises are asynchronous. And that's all I got for you today. Okay, so it's just introduction to promises. Questions? Okay, so let's take a look at the exercise and the reading first today. So there's quite a bit of stuff to look at. Okay. Tomorrow, we're going to be talking about a little bit more about error handling and throwing. Okay. We're going to look at throwing our own errors. Okay. Not just calling reject. We're also going to look at promise chaining and something called promises.all. Okay, what happens when we have lots of things in the oven at once and we're waiting until they all come, they're all ready before we take them out. Okay, but our exercise that's coming tomorrow, make sure you read it. Okay, for tomorrow, I've got 3 pieces of code. This one is just, I want you to run this and I want you to just review, and this is review and understanding. Okay. Create a new JavaScript promise, generate a random number. If the number is greater than 5, it resolves. If it's less than 5, return a negative message. Use the promise with a then catch chain. Do exactly what I did in class, but don't watch the video. Do it without watching the video. Can you replicate it? Can you write it on your own, knowing what I just did? Don't do it right away. Take an hour. Okay, pause, take an hour, try to write it on your own. Now, instead of generating a random number, pass a variable into the promise. Consider wrapping your promise in a function. This time, your promise should do the following. If the value is greater than 10, the promise resolves and returns a positive message. Otherwise, if it's less than 10, it rejects and returns a negative message. And then obviously add in your thens and your catches. And then finally, number 3, rewrite the code, the load script from yesterday that I'll post the solution if I still have it. I do. But mine won't apply to yours because the way you did it might be different than the way I did it. But this time, do it with a promise instead. Do load script with a promise. See if you can do it with a promise. See if you can apply this new concept to yesterday's asynchronous code. Okay, that will really, it's not long. It's like 4 or 5 lines of code. Okay, but trying to apply it is really going to be where you're going to make a lot of progress in your understanding. Okay, so you'll need to start with some JS to get going. It's probably some stuff so at least the load script from yesterday. You will still need that load script JavaScript. Okay, you might need to break it up, but want to see if you can do it. Convert that to a promise. At least some JS to load some JS, okay? And that's it. Any questions? Okay. I'm concerned that either everyone understands or no one understands.
I'll just say, like, I get the concept and I can't really give a lot of feedback before I try it and realize something's wrong.
Okay.
But you'll hear from me.
Okay. Yeah, I know. Fair enough. That's good. Yeah, like, it's not really a hard concept to understand. I feel like, anyways, I don't feel like this is the hardest thing we've ever done. I feel like we've done way harder things than this. And so coming into this, I kind of suspected that everyone would get it pretty well, but just sometimes it worries me when no one says anything. Okay, cool. So there we go. We're done until 12:30. So so Zach is not around from 2:30 Zach is not around in the afternoons, in the second half of the afternoons. He's in the other class, but he is around now until 11:30. Okay, so usually I'll be around in the afternoons, and he'll be around in the morning afternoons. So if you need any help, ping Zach first in the mornings and ping me in the afternoons. I mean, you can ping me anytime, of course. I'm here all the time, but I'm always just working on other stuff and preparing preparing for classes, answering emails, and working on trying to get people internships, which is not going very well right now. Yeah, so we're here. We're available. Go grab a coffee, go for a walk, and then get to work. Do some exercises, do some reading. Okay, I'm not bombarding you with a lot of exercises right now. Do some reading and make sure that while you're working, you're doing your best to work in your terminal. Okay. Speaking of which, I need to open my practice.js and I need to post it. Post the answer. So this is where we're practicing in our terminal, okay? So you should be doing as much work as possible in your terminal. If you don't know how to do something, figure it out. Practice, okay? Try to operate in the terminal as much as you can over the course of the next month. Trust me, it's painful, but it will pay off, okay? All right, I'll see you at 12:30.
Hey, John.
Yeah.
You have like 2 minutes after. I just actually want to talk to you about something like maybe terminal related that's happening with my laptop. That's funny.
Okay, yeah, just stick around. Everyone else can go, or do you want to jump on Discord?
Sure. I'll just message you on Discord.
Okay, sounds good. Okay.